Okay, for now that's enough about the picture that we get from two dominoes. Let's get a little bit more rigorous, and let's say that now we have first of all our XYZ plane, our XYZ coordinate system, a point XY and an interval, an area increment of dimensions delta X by delta Y. Area increment delta X times delta Y. Now, if we regard this as our point, we can come up here to get our point XY, f of XY. If we come up from this point, we can depict the displacement from here to here parallel to the vector I plus fx k. Similarly, in the y direction, we can come straight across. Let's go ahead and kind of sketch this. Okay, I'm not going to explain this sketch as I do it. We've looked at this sketch many times, and here we have a displacement parallel to j plus fyk. And these displacement vectors bound a rectangle the rectangular region above our delta A region in the XY plane. So here's our delta A region. Here is the region that lies above that delta A region. If I sketch this region as viewed from the direction of the cross product of these two vectors, it's going to look just like this. These vectors are perpendicular, one being in a plane parallel to the to the YZ plane, another in the plane parallel to the XZ plane. This vector has a magnitude that's in proportion to our delta Y, determined by the ratio of the magnitude of this vector to the J vector. We could draw a pair of similar triangles to justify that, but what we find then is that this vector has a length or magnitude that's equal to delta Y multiplied by magnitude of J plus fyk divided by the magnitude of J. Now at this point I have to say that something's going wrong here, and I'm still not sure what it is. I'm going to have to write it out a different way, but let's go ahead and sketch in another dotted line on this picture that might make this a little clearer. That's not where the problem lies. The problem lies with the fact that I'm going to then have to say down here that this length is delta x times the magnitude of I plus fx k over the magnitude of I. Now, if we calculate the ratio of the magnitudes, the ratio here is going to be 1 plus Fy squared. The ratio here is going to be 1 plus Fx squared. So that I'm going to get area delta A equal delta X, delta Y, well, delta Y, delta X, equals the square root, and not equal. The area is the length of this side times the length of this side, so that's going to be delta Y times the square root of 1 plus Fy squared. So I'm just going to kind of cross this out. Multiply this by the square root of 1 plus Fy squared to accommodate the delta Y, square root of 1 plus Fy squared that we get here, multiplied by the square root of 1 plus Fx squared. And that's just, I don't think that's right. If I multiply these two square roots together, I get 1 plus Fy squared Fx squared plus plus Fy squared Fx squared. You know, we're going to get this expression here is going to end up as the square root of 1 plus Fy squared plus Fx squared plus Fx squared times Fy squared. And this term here shouldn't appear, and I'm not sure why it is appearing. The argument here seems to be pretty airtight. These ratios, I believe, are correct, and these vectors, being in perpendicular planes, have to be perpendicular, and they're the boundaries of then a rectangle, and that rectangle would have to have this area, but that shouldn't be the case. So let me digress here and develop this from a different point of view, and then maybe we can see which of my assumptions here doesn't work out.